So looking at some triangles that have some different values. Here they want us to determine the ratio using the reference angle, and they want us to write fractions, so no decimals. They don't want decimals. They want fractions in simplest form. So looking at this problem, given opposite over, they want us to find opposite over hypotenuse, and our reference angle is going to be angle A. And if you remember those steps that I gave you before, you're going to use those here. So first thing we want to do is to find the reference angle. So our reference angle, they tell us, is A. So there's our reference angle right there. And now they want us to find the sides. So here's my 90-degree angle. So hypotenuse directly across from the 90-degree angle, and then opposite is going to be directly across from the angle A, and then here we're looking adjacent. So they want opposite over hypotenuse. So opposite over hypotenuse. And so you've got to be very careful whenever you look, and don't just assume that whatever sides they give you are going to be used. So they want opposite. So in this case, our opposite is BC over the hypotenuse is going to be AB. So if we write in the values, BC is going to be 15 over AB. Well, they didn't give us a value for AB, and that's the one we need. We've got to have the hypotenuse. So we've got to find that third side. And the way you find a third side in a right triangle is to use Pythagorean's theorem. So we're looking at a squared plus b squared is equal to c squared, where c is going to be our hypotenuse every single time. So we're looking at 8 squared plus 15 squared will give us c squared. So 8 squared is 64 plus 15 squared is 225. And then 225 plus 64 is going to be 289 is equal to c squared. Well, we want the length of the c. We don't want c squared. So if we take the square root of both sides, c is going to be equal to 17. So there's our 17 for that ratio. And 15 over 17 is in simplest form, so we're good. Looking at the next one wants us to use reference angle B. So now we need to label our sides. This side's going to be our hypotenuse. This side's going to be the opposite. And this side's going to be the adjacent. So if we're looking at adjacent over hypotenuse, we're doing adjacent is going to be BC over the hypotenuse is going to be AB. So BC is going to have a value of 1.4 over AB. Again, they don't tell us, so we've got to use Pythagorean's theorem to solve for that. So we're doing a squared plus b squared is equal to c squared, where c is going to be the value of our hypotenuse. So if we start plugging in the values, we're going to have our a squared is 4.8 plus b squared is going to be 1.4 squared is going to be equal to c squared. Our hypotenuse is the one we're solving for. So we put that in the calculator. 4.8 squared is going to be 23.04 plus 1.4 squared is going to be 1.96, and that's going to be equal to c squared. So 23.04 plus 1.96 is going to give us 25 even. So if we take the square root of both sides, c is going to be equal to 5. So 1.4 over 5. And this isn't considered simplest form. We cannot have decimals in our fractions. So what you need to do To have your calculator give you a fraction for that one, you do 1.4 divided by 5, and it'll give you a decimal. And then somewhere on there is a button that has a little F to a D. You just do second, hit that button, and that'll give you your new fraction, so 7/25. Try that out on your calculator and make sure that you can get that. Looking at the next one, for this one they want us to do opposite over adjacent with a reference angle A. So there's our reference angle A. Here's our hypotenuse. Here is the opposite, and here is the adjacent. So for this one, they want us to do opposite over adjacent. So opposite for this problem with angle A as a reference angle is going to be CB over adjacent, which is going to be AC. So CB has a value of 5 over AC. They didn't give us that value. So again, we're using our A squared plus B squared is equal to C squared, the Pythagorean theorem, to solve for that side. This time we need one of the sides, so I'm going to leave that value be A. So A squared plus our other side is going to be 5, so 5 is going to be equal to, here's our hypotenuse right there, so that hypotenuse will always go in for C, 5 square root of 2 squared. So A squared plus 5 squared is 25 is going to be equal to, and if we put the 5, I'm going to use parentheses around the whole thing, 5 square root of 2, got to close it twice to close it for the parentheses for the square root, and then a second one to close it for the whole thing, squared, is going to give us 50. So A squared plus 25 is equal to 50. Subtract the 25 from both sides. A squared is going to be equal to 25. Take the square root of both sides just to get the side value A, and A is going to be 5. So that's one way to do it. The other way to do it is to notice that this is L, and this is L square root of 2. So that makes this one have to be L. Remember our 45, 45, 90 triangle rules? You could do that too. So AC is going to have a value of 5, and at once simplest form, 5 over 5, is going to have a value of 1. Looking at the last example, given that the triangles are similar, find the given ratio for the given reference angle for both triangles. And so if you look at these, hopefully you see the two different triangles in here. Hopefully you see one smaller triangle right here, and then you see the larger triangle right there. And whenever you do these, draw them out as two separate triangles. So I'm going to draw the smaller one, A, C, B, and they tell you that this is a right angle right here, and then you need to put the side measures on there. So they tell you AC is 4, BC is 3, and AB is 5. So there's your smaller green triangle. And then draw the larger one out separate. And there's A, E, D. And then we need the side length AD, and if we add those two together, we do the 5 plus 5 to give us 10. This side's going to be 6, and then 4 plus 4 to give us 8. And there's our larger triangle that I outlined in yellow. So there's the two triangles, and they want us to do opposite over hypotenuse for both of them using our reference angle A for both of them. So if we do that, and so found the reference angle, now we need to label the sides. There's the hypotenuse, and then the opposite is directly across from our angle, and then adjacents right beside. So opposite over hypotenuse. So if we look at opposite for this one, it's going to be BC over hypotenuse is going to be AB. So BC for this triangle is going to be 3 over 5. So there's the math for the green triangle. Now we've got to do the larger one, still doing opposite over hypotenuse. And opposite for this reference angle here is going to be DE over hypotenuse is AD. DE has a value of 6 over AD has a value of 10. And they want you to write this, and remember to write it in simplest form. 6/10 is going to simplify to 3/5. Okay. And you've got to show the math for two triangles, draw the two triangles out separately, and if you've done everything right, these two values should be exactly the same. So that gives you a good introduction to the trig. The big things for this one are being able to find your reference angles, label your opposite and adjacent sides in your triangle, and be able to set up and simplify those ratios. If you have any questions, write them down on the paper and ask me when you get to class.